Hi guys, welcome back to my channel and thank you so much for clicking. So basically today we're going to handle the enterprise networking project 6, and as you can remember we've covered project 1, 2, 3, 4 and 5, and suppose you've not accessed the classes, I will leave links on the description part of the video or the first comment. Click on the links and get access to the projects. And another option, you can go to our channel Gurutech networking training, then under this section the playlist, click on the playlists, then scroll here, enterprise networking projects. You click on the enterprise networking projects, and these are the recorded projects that we have so far. We had our first project as the simple networking project, then we had a small office, home office network, then hotel management system, then campus management system, and finally bank network design. And today guys, we are going to look into the 6th enterprise networking project. And suppose you're new to this channel, or even if you have not subscribed to our channel, kindly do us that favor, click on the subscribe button, like our video and share this video. Okay guys, so without any further ado, let's start. We normally get projects or case studies from friends, students or clients across the world, and we analyze the case study, design a network and implement the network based on the requirements on that case study. So in this case, project 6, we had a case study from a client. So let me just open the case study, this one. So this was our case study, enterprise networking project 6. A trading floor support center employs 600 staff. They have recently expanded and as a result need to move to a new building. A building has been identified but has no network. This means that before they can move out, new network service needs to be designed and implemented in the new building. Existing network comprises of the following. So we have the new building is expected to have 3 floors with 2 departments in each floor. Okay. So for example, first floor we had sales and marketing department combined to have 120 users. Human resource and logistic department combined have 120 users. And in the second floor we had finance and accounts department combined having 120 users, and also administrator and public relations department combined had 120 users, I mean. Okay. Then finally on the third floor we had ICT department having 120 users and the server room having 12 devices. Okay. Therefore, as a key member of the network team, you have been tasked to design a network for the new building. At this stage, logically design is required, which shows the measures that you would put in place to ensure that the new network meets the current business need and is future proofed. Okay, so guys, we have requirements here. We are required to use Cisco Packet Tracer to design and implement the network solution. Then number 2, use hierarchical model providing redundancy at every layer. For example, 2 routers and 2 multi-layer switches are expected to be used to provide redundancy. Okay, the network is also expected to connect to at least 2 ISPs to provide redundancy, and each router to the connected to the 2 ISPs. I think there was some grammatical errors there, but no problem. It means each router to connect to the 2 ISPs. Okay, each department is required to have wireless network for the users. Okay, each department should be in a different VLAN and in different subnet. Okay, provided a base network of this one, carry out subnetting to allocate correct number of IP addresses to each department. All right. The company network is connected to the static public IP address internet protocol with this one. Okay, to the two internet providers. All right. Number 8, configure basic settings such as hostname, console password, enable password, banner messages, and disable IP domain lookup. Right. Okay. Devices in all the departments are required to communicate with each other with the respective multi-layer switch configured for Inter-VLAN routing. The multi-layer switches are expected to carry out both routing and switching functionality, thus will be assigned IP addresses. Okay, all devices in the network are expected to obtain an IP address dynamically from the dedicated DHCP server located at the server room. All right. Devices in the server room are to be allocated IP address statically. All right. Number 13, use OSPF as the routing protocol to advertise routes both on the routers and multi-layer switches. Okay, configure SSH in all the routers and layer 3 switches for remote login. Okay. Number 15, configure port security for finance and accounts department to allow only one device to connect to a switch port. Use sticky method to obtain MAC address and violation mode shutdown. Number 16, configure network address translation with PAT. PAT is port address translation. Is a part of PAT. It's part of a NAT. To use the respective outbound router interface IPv4 address. Implement the necessary ACL rule. Test communication and ensure everything configured is working as expected. Guys, this is a very long project and a very important project. So we have several technologies that we are going to implement here. As you can see, all of these from number 1 to number 17, from the design to testing communication. Alright, so guys, let's start analyzing this case study. We have read the case study and have identified that there is a company that employs 600 staff. Okay, and the company has 3 floors: first floor, second floor, and third floor. And each floor has at least 2 departments, and in those departments there are respective number of users, okay, or devices in those departments, okay. All right, and after designing that kind of a topology, we are required to implement some technologies. Okay, let's start the design part. We are going to use Cisco Packet Tracer to design and implement the network solution. We are required to use hierarchical network model. You know, hierarchical network model consists of access, distribution or aggregation, and the core layer. Okay, so for example, as you can see here, we have the 2 routers and 2 multi-layer switches are expected. So the 2 routers will be at the core layer. The 2 multi-layer switches will be placed at the distribution layer. Okay, then we'll be having several access layer switches connecting to the respective departments. Okay, so let's do that very fast. I'll go back to a packet tracer and I'll choose this router, 2911 router, 2 of them. Let's place it somewhere here, 2 of them. Okay, and I'll say this is core router 1. And this is core R2, core router 2. Okay, then we need 2 distribution layer switches, and for the distribution layer switches, guys, I will choose this one, 3650. 2 of them, we need 2 of them. Okay, All right, 3650. Okay. All right, so this one I'll say this is I'll just say multi-layer switch 1, and this one also to be multi-layer switch 2. Okay, then guys, we have several departments. We already have the core layer, the distribution layer. So let's implement the access layer. And in the case of access layer, guys, we're going to reference on the number of departments. So I'll open the case study. We had how many departments? In the first floor we had 2 departments, second floor 2, and third floor 2. So we have 6 departments. Okay, so I'll need 6 access layer switches. Take 2960 and place it somewhere here. That is first floor. Let's say that first floor, and then second floor we had 2. And finally third floor we also had 2 departments. Okay, all right, so let's continue reading. The network is expected to connect to at least 2 ISPs, okay, with each router connecting to the 2 ISPs. All right, so let's assume we had ISPs routers there, 2 of them. And for the case of ISP, let me just choose this one, 2911 router, that one. So this one I'll say ISP1, ISP1, and this one is ISP2. Okay, all right. So guys, this is our design, incomplete design, and we need to connect them using the correct cabling. So let's analyze this one. For the case of the routers, I'll use serial connection, and for the case of the routers to multi-layer switches, just the normal straight through cable. For the case of multi-layer switches to the access layer switches, crossover cables, right? Okay, so what is remaining here is to connect them, but before that, let me name these switches very fast. For example, this was HR. Okay, so as you can see, this is sales and marketing department, and this one is HR and logistics departments, finance and accounts departments, administrator and public relations department, ICT department, and server room department. Okay, all right, so let's connect them. So I will need a serial connection between the routers. Okay, all right, so I go to connections, then choose serial with DCE, and when I click there is no serial port, so we need to insert a serial model on the routers. Click on the router, and turn off the router. There is a button here, power button, turn it off, and drag this HWIC-2T to an empty slot, then turn on the router, then do for the rest also. Okay, so we can connect them freely. I'll take serial with DCE, connect here, take the first interface to this one, okay, then serial DCE again to connect here to that one, connect to that one, okay, serial with DCE, connect this one, that one, this one, okay, then this one also, from this one to this one. Okay, so we've connected the ASPs successfully. So now let's do connection between the routers and the multi-layer switches, and in that case I'll use just automatic. and finally between the multi-layer switches to the access layer switches. Okay guys, so as you can see in our topology, we've implemented redundancy, and each access layer switch is connected to at least 2 multi-layer switches, and each multi-layer switch is connected to at least 2 routers, and each internal router here is connected to ISPs. So that is redundancy. That is in redundancy. Okay, so let's include the host devices in each department. For example, I need a PC, a printer, and an access point. Remember, on the case study, there was a point that says each department is expected to have wireless network for the users. So there we'll need access point. So a PC, a printer, and access point. Access point will connect to, let's say, a smartphone or a tablet. So let's just check a tablet here. Okay, and a laptop in each department. Okay, then I go to access points, choose PT, AP, PT, right? Okay, so that is the first department. Let's say it's here. Okay, all right, so what I'll do, I'll copy these to all other departments. So I'll do it very fast to save time. Okay guys, so as you can see, I've copied all the required devices to each department. So what I'll do guys, as you can see, these devices are just connected to any other access point because we've not set any password to the access points. So what I'll do the naming very fast to save time. Okay guys, so as you can see, I've named for the 5 departments, and I forgot something here. On the server room, we are not supposed to include this one. I will include servers, for example, DHCP server, email server, and DNS server, right? Okay, so I'll do that very fast. I will delete this one. Okay, and then a print I'll remove here. Okay, so this one I'll say system admin PC. Okay, to manage the devices. So here we need how many servers? Let's say 3, just for demo purpose. Okay, alright, so I'll do that very fast and name them: DHCP server, DNS server, and email server. Okay, so I'm done as required guys. Okay, so what I'll do is to connect them to the access layer switches, and I'll do that very fast to save time also. Okay, so we have connected all the devices, and as you can see, I'll just try to zoom out. As you can see guys, we have connected all the devices, and as you can see, there is redundancy in our network. Okay, alright, so what I'll do guys is to identify which floor is this one, which department is this one, and I'll do that one very fast. So for example, So we have identified which floors are these. I'll just say this is first floor, okay, and this is second floor, and finally this is third floor. Okay, all right, so do just a minute. Okay, now let's identify the departments. I'll do that very fast. Okay guys, so as you can see, I've identified the floors plus the departments. So what I'll do, I'll just to name the departments very fast. Okay, okay guys, so finally guys, as you can see, we have identified which floors are these on plus the departments, right? For example, this is sales and marketing department, HR and logistics, finance and accounts, admin and public relations, ICT, and finally the server room. Okay, all right, so guys, basically what I'll do, as you can see, these interfaces are in shutdown state. So guys, we need to turn them on, turn them up. For layer 3 switch, this one, it doesn't have power supply, so we must include the power supply. I'll just click on the layer 3 switch and drag the supply and place here. That's done. Come back to this one also, drag the power supply and place there, right? Okay, so that's done. They will turn up. As you can see, now they are oranges. All right, so what I'll do guys, also for the switching, for the routers interfaces, I'll turn them up. Click on the router, come to config, turn this one up, turn on. Okay guys, so guys, basically our design part is almost complete. So I'll just reset so that we can receive the normal size. Okay, so as you can see, I will identify these as the ISP. Let me use blue color. These will be our ISPs. Okay, I'll name them later as we proceed. Okay, so guys, basically I think this is our design, and as you can see, it's beautiful, and the network has redundancy. And now we can just proceed with the configuration part, and I'll just open the case study again and start reading. All right, so each department is required to have different VLANs. Okay, all right, okay, configure basic settings. So guys, we need to start with the configuration, and for the configuration guys, I have already highlighted few steps that we need to follow to configure this network topology here. So these are the steps that I have already highlighted. We are going to start with basic settings to all devices plus SSH on the routers and layer 3 switches. Okay, all right, so let's start with this sales switch. I'll click on the sales switch, enable config T. Then we need to configure hostname to be, let's say, sales switch. Okay, and then also banner MOTD, let's say insert those two characters, let's say no unauthorized access. Okay, then what else were we asked to configure? Console password, enable password, and disable IP domain lookup. So no IP domain lookup. Okay, then line console 0. Let's say password to be, let's just use Cisco for all the password that we'll use here. Okay, then login, exit I mean, and now what's remaining? Enable password. Enable password to be Cisco, I mean Cisco also, right? Cisco. Okay, and guys, there's one thing that they forgot to mention here: to encrypt all the password. Service password encryption. Okay, exit. Right. Okay, so guys, we've configured basic settings on that switch, and any other thing that we can add at the layer 2. Okay, so let's proceed to other remaining devices. So for other remaining devices, guys, I will write the commands on Notepad and copy to all other remaining devices to save time. So let me open Notepad. For example, we need hostname, enable config t. Okay, then hostname, let's say this is HR switch. Okay, then line console 0, password to be Cisco, then log in the user and exit. Alright, so enable password also, enable password to be Cisco also, so I'll copy that one, enable password to be Cisco. Then no IP domain lookup, disable IP domain lookup, no IP domain lookup. Okay, then banner MOTD, 2 characters. Inside the characters you just say no unauthorized access. Alright, so what's remaining here? Service password encryption, to encrypt all the passwords. Service password encryption. Alright, so let me check if I'm leaving anything here. Hostname, console, this one, banner message. Alright, so guys, as you can see, I think I have then do right. Okay, so I'll copy this one to this switch, and for other remaining switches I'll just modify the name and copy, right? So let's do that very fast to save time. Okay guys, so we're done with the layer 2 switches, access layer switches. So we'll proceed to multi-layer switches, and for the case of multi-layer switches, guys, and the routers, guys, we are going to include SSH. Okay, alright, so how do we configure SSH, guys? So first of all, I'll just paste the commands here. I'll just say this is multi-layer switch 1, multi-layer switch 1. Okay, and I copy and I paste. Alright, so let's proceed to configure SSH. The first thing to do when you're configuring SSH, make sure the switch has a username, hostname I mean, not the default hostname but the configured one, right? And then the second thing is to configure IP domain name. For example, IP domain name, let's say cisco.net. Okay, then configure username and password. Username username to be admin, password to be, let's say, Cisco. Okay, good. Then after this one, you create crypto keys. Crypto key generate RSA. Then the modulus length is 1024. Okay. Alright, so line VTY, you enter line VTY 0 to 15. 0 to 15. You say login local to use the local database. Then make VTY login to use only SSH. Transport input SSH. Exit do right. So guys, I'll write the commands also on notepad and copy to the switches and the routers. Alright, so the first thing to do is to configure IP domain name, let's say cisco.net. okay, remember we have configured host name here. Now this is switch multi switch 2. We have configured host name, so we proceed to configure domain name. Then username, let's say admin. Which did I use admin with A to be D, capital A, or just let me just confirm, just a minute. Small a, right? Okay, no problem now. So admin password to be Cisco. Okay, then crypto key generate RSA. Then you hit enter 1024 modulus length. Okay, then enter line VTY 0 to 15. Login local. Okay, use the local database. Then allow only SSH to be used for remote access. Okay, transport input SSH. Exit the interface and do right. So guys, I'll copy this to the remaining layer 3 switch and the routers. So what I'll do is just to modify names here. This is for switch 2, which is this one. Now for the router, I'll just say this is core router 1, core R1, okay guys. So guys, we're done here. I'm not going to configure ISP routers. I don't have control over the ISP routers. Okay, so I will not configure them. What I'll just configure for demonstration purpose is just IP address to these interfaces. Okay, but hostname and all the rest I won't configure on the ISP routers. Alright, so guys, also I've forgotten something, the version of SSH. So let's configure the version of SSH IP. SSH version to be version 2. So do right. That's done. Let's configure version of SSH very fast. IP SSH version to be version 2. Do right. Okay. Then to the routers also. Okay, now we are done. Now we are done, guys. Alright, so we are done with the first step. The first step was to configure. As we analyze our config steps, the first step was to configure basic settings to all devices plus SSH on the routers and layer 3 switches. Now, the second step is to configure VLANs and assign ports to the roles of access and trunks on both the layer 2 and layer 3 switches. And now I'm going to combine step 2 and step 3. Switch port security to finance department. When I will reach finance department switch, I will configure switch port security. Okay, so guys, let's start with assigning VLAN numbers. Okay, so what I'll do, guys, I'll say this is VLAN 10, 20, 30, 40, 50, etc, etc. So let me do that very fast. Okay, now that's done. Now let's start configuring VLANs to sales department switch. Okay, and remember, we need to assign ports role of trunk and access. For example, when you analyze this switch here, all the interfaces that are connected to the layer 3 switches will be trunk ports, and all the interfaces that are connected to the devices are access ports. So for example, this one is FA0/2 and just a minute, FA0/1 and FA0/2. So during my cabling, it was a pattern. For example, this is FA0/1, FA0/2, FA0/1, FA0/2, etc, etc. Okay. Okay. So I'll just click on this switch here and begin configuration. Cisco password of Cisco, enable Cisco. Alright, so config T. So interface range FA0/1 to 2, this one and this one. Okay, it's a pattern. The two interfaces of all the layer 2 switches that are connected to the layer 3 switches are FA0/1 and FA0/2. So there must be trunk ports. Okay. Alright, so switch port mod trunk. Okay, exit. Now let's create VLAN. VLAN 10, name sales. Okay, exit. Now let's assign ports to that VLANs. So for example, from FA0/3, which is this one, to FA0/24 should access VLAN 10. So interface range FA0/3 to 24. Remember, a switch has 24 ports, fast Ethernet ports, plus 2 gigabit Ethernet ports. Okay. Alright, so we are not going to do anything with the gigabit Ethernet ports. So in this case, just fast Ethernet ports. But for the gigabit Ethernet ports, you can just assign them to another VLAN and shut them down. Okay. Switch port mod access, then switch port access VLAN 10. Okay, exit, do right. So guys, what can we do with the gigabit Ethernet ports? Let's assign them to another unused VLAN, which is called VLAN 99, name black hole VLAN. Okay, exit. So interface range gig 0/1 to 2, switch port mod access, then switch port access VLAN 99. Okay, then no shut down those interfaces. Shut down. All right, exit. Do right. So guys, I'm going to copy those commands on Notepad and copy to the remaining layer 2 switches. Okay, remember we are creating 2 VLANs on each layer 2 switch. The first VLAN is to access the ports and to access the usable ports, and the second VLAN is to access the unusable ports. Okay, all right, so let me just do that very fast. I delete those. The first configuration is to configure the first 2 interfaces to be trunk interface range FA0/1 to 2. Sorry. Switch port mod. Switch port mod trunk. Exit. Okay, now we go to another range. Switch port interface range FA0/3 to 24. 24. Switch port mode access now. Okay, then copy. Switch port access VLAN 20. VLAN 20. Before that, let's create the VLANs. VLAN 20. Name, let's say this is HR. Another VLAN is VLAN 99, which is black hole. Name black hole. Okay, then exit those in VLAN interfaces. All right, so guys, I've created the interface range, this one to this one, to access VLAN 20. Exit. Then another range should be gig 0/1 to 2. Okay, access VLAN 99, which is black hole. All right, so do right. Okay, so I'll copy everything and paste to HR switch, and for other remaining switches, guys, I'll just modify the VLAN number plus the VLAN name. Okay, for example, it will be VLAN 30, name finance, then here access VLAN 30. But for the black hole VLAN, it's consistent to all other switches, right? Okay, so I'll go there, and I don't want to sign in using passwords, so I'll just say exit and paste. Right, so that's done. Then I move to this switch here. I do it very fast, save time. Okay guys, so guys, as you can see, we have configured the VLAN numbers, the VLAN to every department. And guys, as you can remember, I said I will combine step 2 and step 3 for in the case of the finance department. So I'll proceed to finance department and configure switch port security. Okay, so interface range FA0/3 to 24. Okay, switch port security port security, then switch port security maximum to be only 1, then switch port security MAC address to be sticky command, the way it was said here. Remember here, where is it? It was somewhere here. Let me just try to check it out. Just a minute. Configure port security to finance and accounts department to allow only one devices to connect to switch port. Use sticky method to obtain MAC address and violation mode of shutdown. So that's what I'm doing. So all of these ports should be accessed using one device at a time. Okay, one device I mean. Okay, then you're going to use sticky method to obtain MAC addresses, right? Okay, then switch port security, violation mode of shutdown, exit, do right, do show port security. Alright, so as you can see, it's there. Alright, so guys, I think we're done with step 2 and step 3. Step 2 and step 3 on layer 2 switches. So guys, I'll proceed to layer 3 switches. Okay, so for layer 3 switches, we won't have access interfaces, because if you pay close attention to these switches here, guys, layer 3 switches, they are connected to the switches and the routers. Okay, so any interface that is connected to the layer 2 switch will be trunk, but any interface that is connected to the layer 3 switches will be a layer 3 interface and no switch port. Let's proceed. So for Inter-VLAN routing that we'll cover later in this project, we have to configure VLANs. So for example, we have how many VLANs here? 6 VLANs. 10 to 60. 10, 20, 30, 40, 50, 60. Alright? Okay. So we'll configure the 6 VLANs to all these switches. Layer 3 switches, I mean. Okay? Alright. So what I'll do, I'll just proceed. I'll delete everything and configure these ports as trunk ports, this one and this one. Okay, so let me just identify which ports are this one FA, just a minute, FA 0/3 to FA 0/8, I believe so. Just a minute. Yes, so FA 0/3 to 8 should be trunk ports. Okay, but this one will be layer 3 interface, of which I will configure later in this project. So let's deal first with the trunk interfaces, then we configure VLANs, we create VLANs. Okay, so I don't want to sign in using password, exit. So interface range, it's gig, just a minute, gig 03 to 08. Interface range gig, just a minute, it's 1, just a minute, 103. Okay, so interface range gig 103 to 8. Okay, switch port mod trunk. Okay, exit. Alright, so I'll do the same for the other switch. So then switch port mod trunk, save time. Then I'm forgetting something. I should create VLANs and name them. Alright, so VLAN 10, name sales. VLAN 20, name HR. Let me just copy these. We have 6 VLANs here. Okay, VLAN 30, name finance. VLAN 40, name admin. VLAN 50, name ICT. And finally VLAN 60, name server room. Alright, so exit, do right. I copy and paste here first. Good, so we have the VLANs there. Now let's move to this switch also and configure the required interfaces plus the VLANs. Exit and I paste. Okay, alright, so guys, what's remaining? Let's just go to config steps. Okay, subnetting and IP addressing. Guys, very important, very important. Remember, in our case study here, all devices are in the network are expected to obtain IP addresses dynamically from dedicated DHCP server located at the server room. Devices in the server room are to be allocated IP address statically. Okay, so we must start with the allocating with manual allocation of devices in the server room. Okay, alright, so let's proceed, guys. Let's proceed. Just a minute, I'll open our case study again, and this was the base network that was given. So we need to carry out subnetting and allocate the correct number of IP addresses to each department. Guys, subnetting takes a lot of time, and I've already done that earlier to save time. So this is our addressing table. Okay, so for sales department, we had this network and this subnet mask. Remember, in sales department we had only 120 devices. So this subnet mask satisfies the number of required hosts. Okay, in the HR departments, this network and the subnet mask, and so on and so forth. And now on finance department is this network and this subnet mask, as you can see. Okay, third floor also this network and this subnet mask satisfying the number of required devices. And finally, between the routers and layer 3 switches. Remember, we said the layer 3 switches will provide both routing and switching technologies. So we must assign IP addresses to the layer 3 switch interfaces. Okay, then finally here between the routers and here should be ISPs. Okay, we are going to use this one as provided here in the case study, this one. Okay, so it's very simple. So what I'll do guys, I'll proceed to allocate the networks on the network on our diagram here. So for example, here was let's say net to be 172.16.1.0/25. okay, so because in server room we had only the number of required devices were only 12 here, as you can see. So the subnet mask changed to /28 notation. Okay, alright, so I'll do to allocate the network addresses to between the routers and the layer 3 switches. I'll do that very fast. So as you can see, between the multi-layer switches and the routers, we will be having these networks as provided here in the addressing table. Okay. All right. So let's proceed to provide addressing to between the routers and the the core routers and the ISP routers. Okay. Using this addressing table. Okay, so guys, it's done. So what's basically is remaining is to assign IP addresses to these interfaces. Okay, so as you can see, our config step was to subnetting and IP addressing. All right, so we need to assign IP addresses to these interfaces of the switch, these interfaces of the switch, and of the routers also. Okay, so I'll start from the switches, which is FA0/1 and FA0/2. Okay, and to assign IP address to a switch, a layer 3 switch interface, you must make that interface to be a layer 3 interface. By default, they are switch ports, so you must make it to be a layer 3 interface. So what do? Interface range, it's FA0/1 to 2. Sorry. It's gig. I mean, it's gig 10. Sorry, it's a gig 101 to 2. Just say no switch port. Okay. So now the two interfaces are layer 3 interface. Then I come on this side also, interface range gig 101 to 2. No, just say no switch port. Okay, do right, exit. Now let's assign IP addresses to those interfaces. Remember, now they are layer 3 interfaces, they are routable. Okay, so for example, this is gig 101. It will take 172.16.3.145. now this take 146. Okay, it's because subnet mask is /30 notation, so we only have 2 usable IP addresses. Okay, so the first one is interface gig 101 IP address. It's 172.16.3.145. let me check again. Yes, 3.145. that's okay. And subnet mask of 255.255.255.252 because /30 prefix. Okay, then no shutdown, exit, do right. Then let's go to the other interface, which is gig 102. Then IP address will be 149 because this is a network, so IP address start from 149 and 150. Okay, so I make it 149. Okay, then no shut, do right. Okay, that's done. Let's move to this switch. So this is gig 02 and this is gig 01. So gig 01, IP address to be 172.168.3.153. Remember, this is a network. 152 is a network. 153. Then a subnet mask of 255.255.255.252. Okay. No shut. Exit. Then the other interface, which is or 2, IP address will be sorry, I forgot something here. Here should be 156. 144, 148, 152, 156 rates. So that one will be 157 now. This one will be 157. Okay, no shut. Do right. Okay, so guys, we've assigned IP address to the 2 interfaces of the layer 3 switch. So let's do on the router. I'll start with this router 1, core router 1. So interface gig 00 is connected to which switch? This one. Interface gig 00 is connected to this switch, which is IP address will be .146. Okay. So IP address will be 172.16.3.146. Okay, because this one took 145, and IP address is 255.255.255.252. No shut. Exit. Let's move to this interface, gig 01 now. Now gig 01 will be gig 01. IP address will be gig 01. IP address will be 154 because 153 was taken by this interface, right? Now it's 154. 154. Okay, no shut. Alright guys, so let's proceed to configure IP address of today's serial interfaces. To the serial interface, for example, this is serial 2021 and this one is serial 020. So let's start by serial. Exit. Interface serial 020. And guys, these are one of the most important concepts here. These are serial interfaces with the DCE. Now we have to configure clock rate. If you hover over this interface here, you will see a clock sign. Okay, you will see something like a clock sign, meaning it's serial DC. So we must configure serial a clock rate. So let's say clock rate to be 64,000. Okay, and now IP address will be a public IP address, which is this one. IP address will be that one. .1 subnet mask of 255.255.255.252. Okay, no shut. Exit. Now the second serial interface, which is that one, and clock rate also that one, and IP address. Now IP address will be .5. No shut. Exit and do that. So guys, we are done configuring IP address to this router here. So let's move to this router and finally to these routers here. So let's start by gig 00. So gig 00 is connected to which router? This one. Gig 00 is connected to the first multi-layer switch. Just a minute. Yes. So it should take IP address of this one, which will be .150 because .149 was taken by this interface. IP address should be 150. Subnet mask of 255.255.255.252. No shut. Exit. Then gig 01 is connected to the other switch, which will take .158 because .157 was taken by this interface, right? Okay, so it should take 158. I mean, yeah. IP address should be 158. I think. Let me verify. Yes. Hit enter. No shut. Exit. Now let's configure IP address to these serial interfaces with the DCE. Which one is this one? Serial 020. This one is 020. Yeah. So 020 interface serial 020. IP address should be this one .9 now. Okay, this one is serial 020. Yes. So IP address should be that one .9 255.255.255.252. No shut. Then clock rate, because it's a serial DC interface with a clock rate 123. Exit. Then serial 021 clock rate first, no shut, then IP address. Okay, IP address will be this one .13 now. Okay, .13. Do right. Exit. So guys, what I'll do, I said I will not interfere with the ISP routers because I don't have control over them, but for the demonstration purpose I will just configure IP addresses to these interfaces. Okay, and a little bit of routing protocol. Let's say OSPF here. Okay, so this one is just a minute. This is serial 030. Serial 030 should have IP address of I'll just use GUI here. Copy, and I come here and I locate here .2 because .1 was taken by this router's interface, and subnet mask will be 252. That okay. Then we move to the other interface, which will take this one .10. Okay, on the subnet mask, that one I'll just say do right. Okay, then now to this router, serial 030 is connected to this network, which is this one, so it will take .6 30 take .6. This is 252. Okay, and the remaining of this one will take .14. Okay, because .13 was taken by this one. Okay, .14. Okay, now it's fine. Do right. Okay guys, so guys, we are done with the fourth step, and now we are going to configure OSPF on the routers and layer 3 switches. Okay, so allow me to close that one first. You know, this layer 3 switch is connected to how many networks? 8 networks. the 6 networks of these departments plus these 1 and 2, those are 8 networks, I mean. Okay, the first network is this one, 1, 2, 3, 4, 5 and 6, then 7 and 8, also this one, 8 networks. So we need to advertise all of these networks. Okay, right, exit. The first command, guys, we need this layer 3 switch to carry out routing. The first command is to enable routing, IP routing. It's enabled now, so we can proceed to configure OSPF. Make the switch aware that it's using OSPF of the routing protocol, route OSPF. Let's use area 10, a network. The first network is this one. Copy and I paste here .0 and the wildcard mask of this is /25 notation. /25 notation is equivalent to 255.255.255.128. So 128 minus 2555 is equivalent to 127. So the wildcard mask will be 0.0.0.127, area 0. Okay, another network will be 128 for this for HR department. Then the third network will be 2.0 for finance, then 2.128 for admin, 2.128 for admin, then 3.0 for ICT, and now finally 3.128 for server room. But now for the case of server room, it has different subnet mask, which is /28 notation. Remember, this had the same subnet mask of /25. Okay, now this is equivalent to a wildcard mask of 0.0.0.15, because /28 notation is equivalent to 255.255.240. So 255 minus 240 is 15. So I'll come here and change this one to 15. Okay, now let's advertise these two networks here, this one and this one, which is 152 and 156. Copy network, I paste that one, and now /30 notation, wildcard mask will be 0.0.0.3, because subnet mask is 255.255.252. So now 255 minus 252 is 3, area 0. Okay, another network is 156. Okay, then we are done now. I think we have advertised all the 8 networks. So let's proceed to advertise other networks to the other switch also. I'll copy. Sorry. I'll try to copy these so that I don't repeat myself. Copy and paste to our notepad here. Now what I do is just to remove this one. Okay, the first configuration that you must do is to enable routing, IP routing on the layer 3 switch. Then make the switch aware that it's using OSPF protocol with the process ID of 10. Okay, now I have to advertise the networks. And guys, I have to add something. I want to add something here. Let's configure route ID. Route ID. Let this one to be 1.1.1.1. Okay. Alright, so I'll move to this switch, config T, and paste the 2 there. Alright, so do right, exit. Okay, so we have configured route ID to this layer 3 switch, and we will do to this layer 3 switch. So these are the networks that we want to advertise on this switch here. But remember, we have not included this one also. So I will include this one also. There are 2 of them. So I'll come here, come to the layer 3 switch and copy this one that has .3 and paste twice, 1, 2, and now modify 3.144 and 3.148. 144 only that, 148. Okay, now guys, we are done. We have enabled routing on that layer 3 switch. Then OSPF area 10 process ID, OSPF with the process ID of 10, then router ID. Route ID now should be 22222, okay, because this one was 1.1.1. okay. Alright, so we'll just try to paste, exit, come here, I copy everything, then I come and paste. So I can see an incomplete the first one is not complete. I don't know why. It should be area 0. Let me just delete it because it's already here. Okay, 1. Okay, it's fine. It's okay. Okay, so guys, we have advertised how many networks? 1, 2, 3, 4, 5, 6, 7, and 8. That's done. So what I'll do right. So I move to the routers, this router and this router. Advertise how many networks? 4 networks. This one, this one, this one, and this one. Okay. So router I will do, let's say it's 3.3.3.3, okay, for this router here. And we have advertised how many networks? The first one is this one, the second is this one, 152, okay, this one and this one. So the third one is this one and .4. So network, that one also, copy, and I paste here. Then I copy all of these and I paste here to be .4. okay, this one, this one, this one, and this one. Okay, 144, 152.0.4. okay, so do right, exit, copy. Now for the routers, we don't need this first command, which is IP routing. I copy, exit, and I paste here. Alright, so it's okay. Then we move to this router here to check how many networks we need to advertise. So this one, which is .8, then .12 also, .12 and .148 and 156. And now ID will be 4.4.4.4. Copy to this router, paste. Alright, so let's move to ISP routers. That is the last thing that I will configure on the ISP routers, because we don't have control over the ISP routers. We're just doing this for demo purpose. Okay, for ISP routers, they will only advertise how many networks? 2. For example, this one will advertise this one and this one. So without further ado, let me do that very fast. I will remove this one and make this one 5.5.5, 5.5.5.5, and this one .0, and that one is .8. So let's make this a .0, the 2. Okay, move here, exit and paste. Okay, then I move to this one. So that one will advertise .4 and .12, 4 and 12, .4 and .12 for, then yes, .12, copy and paste. Okay, so guys, we are done configuring SPF, and I'll just click on the routers to see if there's any adjacencies formed. So as you can see, these routers has formed adjacencies, 3 of them. This one is still loading, and this switch has formed how many adjacencies? 2, because it has this one as a neighbor and this one. Also this switch, how many adjacencies? It does not form adjacencies. So guys, we had a problem here. As you can remember, when we were configuring user ID here, router ID, we did that mistakenly, right? Because we were supposed to do that before advertising the networks. So we are being told here to reload and use clear IP OSPF process for this to take effect. So what I'll do, I'll just copy this command here, or I'll just do it later. Let me just reload, do reload. Yes. So let's give it time so that it can load, and we clear IP OSPF process so that it can take effect. Cisco enable Cisco config do show OSPF neighbor. Do show IP OSPF. It has not formed any neighbor so far. Let's give it time, it's still booting. Okay, so we'll return there some other times. Remember, the mistake that we did was this one. We advertised the network before we could configure route ID. That was a mistake. Or I can just do this one first. I can just copy, do show SPF neighbor, do clear, reset all, yes. So what I'll do, go back to our guide here, static IP address to server room devices. Okay, all right, so let's go to server room devices and configure static IP address to these devices here. So for example, they should take this network here, dot 240 or /30/28 notation. So let's start with our DHCP server. DHCP server will be, let it take dot 30, and this one will be 255.240. okay, and default gateway will be .129. okay, we will configure default gateway on layer 3 switches when we are configuring Inter-VLAN routing. And now DNS server, this one, we want to make DNS server to have IP address of .131 here. okay, all right, .131. okay, let's close that one. Go to this PCME, let it have 132, and IP address subnet mask 255.240. Default gateway will be 129, DNS server 131. Then we go to DNS server, it should be 131 as we have said, 255.240. Default gateway will be 129. okay, and that's just enough. I don't need to configure email server now because of time. All right, okay, so let's proceed. DHCP server device configuration. Let's go back to DHCP server device configuration to create pools. Remember, we want to have these devices here in these departments to obtain IP address automatically from this device here. okay, so I click on DHCP server, then you come to services, then DHCP. okay, enable here. Then let's create pools, sales pool, and the network was default gateway should be 172.168.1.1. okay, DNS server is this one, .131. okay, right. Okay, so this one start IP address should be, let's say, .6. okay, a subnet mask of it was 128. okay, maximum number of users it should be 120, and add. okay, sales department, you can see here we have that one, default gateway that one, and start allocating IP address from 1.6, yes, and subnet mask should be 255.128. okay, all right, so let's move to another pool, which is HR pool. HR pool should be 1.128, and default gateway should be 129. okay, because just let me just show you, because 128 was a network, so we'll proceed. okay, then start providing from 130, let's say 130, 136, 134. okay, HR pool, then you had, let me check on HR pool again if it's correct, DNS server is correct. okay, now let's go to finance pool. Finance pool should be 2.0, this one 2.0, and start locating from 1.6. okay, and this one is just fine, and you had, then admin pool should be 2.129, default gateway, then start allocating from 134. okay, everything remains the same, and sorry, so this one should be 2. Add, then you come to finance here, this one should be 2. Save. Okay, all right, so let's go to ICT department. I believe so. ICT department should be, ICT pool should be 3.0 and 3.1, I mean, sorry, and here should be 3. Okay, and you had, so there's a one place I made error. This one is correct, it's correct. Finance, this one is not correct, 2.1, should be 2.1. This one is correct, this one is correct, this one is correct. Now save. Then I move to admin pool, 2.1, that's correct, this one is correct. HR pool, this one is correct, this one is correct. And finally sales pool, that's correct. Okay, all right, so we have done that. We have configured the DHCP server device. Now let's do that for, let's also do for DNS server. Come to services, come to DNS and enable that service. Let's say www.gtech.com. okay, and IP address should be that one, and save. Sorry, add. Okay, so that's done. We've configured the DHCP server. We've created how many pools? We've created 5 pools. We could not, server room department we are configuring statically. Okay, all right, so let's proceed. What's next? Inter-VLAN routing on the layer 3 switches plus IP DHCP helper addresses. Okay, let's do that one very fast. We need to configure inter-VLAN routing on these 2 switches, this one and this one. Okay, all right, so I'll start with this one. Exit. All right, how do we configure inter-VLAN routing? Remember, we have already created VLANs here on this switch, so we just say inter-VLAN interface VLAN 10. Okay, no shutdown. IP address, we allocate IP address to be 172.168.16, I mean .1.1, subnet mask of 255.255.255.128. okay, then IP helper address should be IP address of the DHCP server, okay, which is 130. I copy. So that's our helper address. I paste here. Okay, very simple. Exit. Then I'll just open Notepad again. Interface VLAN 10, no shutdown. Then IP address to be 172.166.16.1.1, subnet mask of 255.255.255.128. Then IP help address, I'll just copy this one and I paste there. Okay, now that's done. We move to VLAN 20. Now for interface VLAN 20, the IP address will be 129 here. Okay, everything remains the same. We copy this also, paste. Now this is 30 and this is 40, and for 30 it was 2.1, everything remains the same, and for 40 it was 2.129, everything remains the same. Okay, now finally the two VLANs VLAN 50 and 60, 50, which was 3.1, okay, and for VLAN 60 it was 3.129. Everything just remains the same here, as you can see, and copy, and you paste to all these switches, okay. Do right. I go to this switch also and I paste. Do right. So it's very simple. Inter-VLAN routing, you just enter the VLAN interface VLAN 1, VLAN 10 I mean, IP address of that interface, then you include IP helper address, and the address should be the IP address of the DHCP server, okay. Alright, so let's see the next step, that is there. Okay, wireless network configuration. Guys, this one is very simple. That is very simple. So for example, this is sales access point. Let me copy sales access point, port 1. SSD should be that one, and password this one, let's say the same, 1 2 3, okay, no problem. Then you come to this laptop here. For laptop, it doesn't have any Wi-Fi card. Now turn off, remove the existing card and drag this one and turn it on again. Then come to desktop, PC wireless, connect and refresh. We need sales AP, this one. You connect and the password is 1 2 3 and connect. Okay, it's done. Come to this tablet, config wireless 0, SSD is sales AP, password is sales AP 1 2 3. Okay, so guys, I'll do that for the remaining access points very fast to save time. Okay guys, so as you can see, I've connected all the OX devices to the respective access points, and each device is connected to the access point in every department. Okay, all right, so we have a problem here, but I'll sort it out, don't worry. So that's done. Okay, so let's proceed. Configure port address translation plus access control lists. All right, so we need to configure port address translation plus access control lists, network address translation, NAT. Okay, so what did the statement say in the project? Let me just read it. Configure part to use the respective outbound router interface IPv4 address. Implement the necessary ACL. Okay, very simple. So we are going to configure NAT on these routers here. I don't want to configure NAT on the switches. I want to just configure the NAT on the routers to use the public IP addresses, right? We are going to use the public IP addresses. Translate private into public IP addresses, because it's on the routers here that they have public IP addresses assigned to their interfaces, but not on the layer 3 switches. Okay, so we'll start with this router. Click and okay, how do we configure port address translation or NAT overload? So IP NAT inside source access source, just a minute, let me query source list 1, access control list 1. Let's just use access control list 1. Then interface interface, we're going to use which interfaces? Serial interfaces, this one and this one. There are two interfaces, so it's serial 0/2 and serial 0/21. Okay, serial 0/20 and serial 0/21. Okay, interface serial 0/20, then overload. Okay, then another one is serial 0/21 overload, because we need to use two interfaces, redundancy in the network. Okay, in case this link fails, it will use this one for translation. Okay, all right. Okay, so let's create access control list and permit the various networks access. List 1, permit. We are going to permit how many networks? 6 of them. This one, this one, this one, this one, and this one. Permit. I'll copy this network. Copy. And I paste here. Permit that one. Okay. Hit enter. Then another one will be 128. Access control list permits this network also. Then another one will be 2.0. Another one will be 2.128. Another one will be 3.0. Then 3.128. Then a different subnet mask 128, and the subnet mask will be, let me just see here, wildcard mask, I mean dot 15 here. Now here will be 15. Okay, all right. Okay, so let's configure interfaces to act as NAT inside and NAT outside. For example, on this router here, you know, this interface will be accepting traffic in from these networks, either of these networks. Okay, and this interface also. So this one and this one will be NAT inside. Let me expand this one. This one and this one will be NAT inside, but this one and this one will be NAT outside. So it's interface gig 00. So interface gig, let's say just a range gig 0/0 to 1 IP NAT inside. Yes, exit. And now this one and this one, which is serial interface range serial 0/2/0 to 1. It doesn't work, so I'll just do it individually. IP NAT outside, IP NAT outside. Also this one also 2.1 IP NAT outside. Exit and do right. So guys, we're just done configuring NAT there, and what you need to do is to copy the configuration that we've done here to the other router here. Okay, so I'll try to copy this one, copy, so that we can go very fast. So what I remove is just this one. All right, and the first one was the first two, this one. Okay, so I can proceed to the second router and configure the same. Exit. So I will copy all these. Copy. IP NAT overload. Which interface they use on this router? This one and this one, which is serial 020 and 021. So I copy, I paste that one. Right. Now let's configure interface NAT inside and interface NAT outside. So interface range gig 0/0 to 1 IP NAT inside. Exit. Then interface serial 0/2/0 IP NAT outside, and also 2.1 IP NAT outside. Exit and do that. So guys, we've configured NAT, and if I can say do show IP NAT translations. Okay, we have not do right. We've not pinged outside the network. We've not pinged outside the network. All right. So let's see what's next. So basically, what's remaining is just to verify the configuration, guys. And before we verify the configuration, guys, I want us to configure the last thing. Let's say 10.1.1. So here I'm going to configure default static route. So for example, let's just say this host wants to ping a network that is not found on the routing table. How will the routers forward that traffic? So that's the concept of default route. So in the case of default route, guys, I'll just I'll just write the command and paste in all the routers. IP route 0.0.0.0, any IP address with any subnet mask, okay, should be routed through each interface. So let's use this as primary gig. It will be gig 010, and this one as secondary, which is gig. This one is gig 012. So it should be routed through gig 101. I think that's it. Yeah, 101. That's the primary, and now the secondary should be backup. Should be in case that interface fails. Okay, redundancy 2. Then let's give it administrative distance of let's say 150. Okay, so we can use 150 or just let me just use 70. 150 is too much. Okay, so I'll copy this to the two layer 3 switches, this one and this one. Exit and I paste. Do right. Okay, do right. So I say do right. I go to this switch also. Okay, and now let's configure default routes on the two routers. So let's use this one as the main active one, and this one as the backup. Okay, so what I'll do, I'll just change it to be serial 0/2/0, and this one will be copy 2/1. Okay, for the two routers. Okay, very simple guys. Then we are done. Paste. Thank you. Here. Paste. Alright, so we are done guys with everything, and what's remaining is just to verify the configuration. So we're going to verify the configuration and test configuration. Alright, the first thing, let's test DHCP if it's functioning. I'll just do this and come to DHCP, close this one, printer also, go to DHCP. Okay guys, so I've enabled DHCP on the devices, so I'll just check if they have picked IP addresses. As you can see, they have picked IP addresses. They have picked IP addresses as specified here. And let's check the wireless devices. And did the wireless devices pick the IP addresses? For example, the PC, the laptop, as you can see, is fine. And now let's come here. It's fine. And now the tablet, it's fine, it's picked. Now this one, okay. And now we have a problem here. As you can see, this access point, I don't know what's wrong with the access point, but I'll just fix it out. But as you can see, it has picked IP address. Alright, now this one also, DHCP is working here. And then what about the laptop here? It has picked. And let's go here. As you can see, it has picked. And PC here, it has picked. Alright guys, so let's try to ping. Let's try to ping from this PC to this PC. So ICT PC is the IP address is 3.9. So let me try to ping 3.9. Ping 172.116 Let's just give it time, see if it's pinging. Okay, so that's successful. That's good. I'll try to test SSH. I'll test SSH. I'll test SSH on this router. Let's say this router using which IP address? Let's use this IP address, this one. Okay, so I'll try to access SSH. So SSH -L, then username was admin, and IP address is this one. Password Cisco. As you can see, it's core router 1, and the banner message no unauthorized access, enable. Then Cisco also. Alright, so guys, I think everything is working fine. And for the error we had at the finance department, we can exclude the port from the port security. Remember, we configured the port to access only one device, but you know it's connected to access point, so we have to exclude it from port security. Okay, all right. So I need to exclude this port FA0/5. So I'll go to FA0/5 and exclude it and say no. Switch port security. Okay, then no. Switch port security maximum 1. Then switch port, then no switch port security MAC address sticky. then no switch port. We're just going to reverse the initial configuration. Switch port, port security violation, shutdown. Okay, so guys, what we've done is just to reverse the initial configuration. Okay, all right, so let's check it. It's still not showing up, but I believe it will show up. Do show start. So it's this port, this one. Okay, so as you can see, it doesn't have any switch port security configuration on it, meaning now it's okay. It will become okay. What I'll do is just interface again. Let just a minute. This one, shut down. Okay, no shut. Change status. So as you can see, it will turn green again. Okay, all right, so let's just give it time. It will turn green. Okay, all right. So guys, let's try to ping this ISP. Now guys, let's try to ping this ISP device. Okay, it has IP address. Let's just take the IP address of any interface. This one, I'll copy and use which one, even this PC, to ping it. Ping. It's pinging. Now, being that the traffic has passed either of these routers, then it must be translated. Now let's go to these routers and check if NAT is working. Do show IP NAT translation. Translations. Translation. As you can see, guys, so NAT is working. NAT is working. Inside local, the IP address of that device that we used to ping the router was this one, and inside global is the IP address, the translated IP address. Okay, outside local is that IP address of the IP address of the destination. Okay, alright guys, so guys, I believe everything is working as expected, and what I'll do, guys, is to make them look beautiful. For example, this is a ISP router. What I'll do this one and include cloud there, place it there. This one also, do this cloud and place there. So this one say ISP1 main, copy. ISP2 backup. Okay, all right, so what's remaining here? What's remaining here actually is nothing, and just to use some, let me just use something here. Okay, so this one is OSPF area 0. We've used OSPF here. OSPF area 0. OSPF area 0. Okay, all right guys, so basically I think our project is completed, and nothing is remaining here. So basically, guys, I think everything is configured, and I'll try to check what is remaining. OSPF is working successfully. SSH is working. Port security is working. PAT is working. DHCP is working. Inter-VLAN routing is working, and so on and so forth. Guys, this was a very long project, and it has took us a lot of time, and I believe you've learned a lot on this project. You've learned how to design a network based on a case study, implement that network based on the requirements, and implement several technologies that you've been asked. Okay, alright, so that will mark the end of this class. Suppose you like this project, suppose you like this video, please like this video, subscribe to our channel, and drop an encouraging comment below. Thank you so much, and let's see you again in Enterprise Networking Project 7. Bye guys, and see you.